Blockchain is changing the face of the internet as we know it. One way in particular is how online communities organize. And in this video, I'm going to show you how to jump on this trend by creating your own blockchain-based Discord clone that uses NFTs for membership. This is an amazing project to learn the fundamentals of blockchain development, how NFTs work, smart contracts, wallets, etc., etc. And it's a great project to use for your portfolio if you're trying to land a highly paid Web 3.0 job. So you don't have to be an expert to get started today. I'll show you all the programming skills and technologies as you go. And so if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. And I put a ton of time into making this video just for you. And the only thing I ask in return is that you smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you like what you see in this video today, and you want to level up your blockchain skills, break into the industry, increase your salary well past 100K, I can show you how to do that over at dappuniversity.com/bootcamp. Just click the link down below to get started today. All right, so let's look at what we're going to code together in this tutorial today. This is a blockchain clone of Discord called Dapp. Okay, so Discord is a very popular application in the crypto space because it's one of the top ways that other crypto people communicate with one another, particularly NFT holders. So how this is going to use blockchain is basically people are going to become members of this channel by connecting their Ethereum wallet or their blockchain wallet, and then they have to hold an NFT in order to join an individual channel, okay? And once they're in that channel, they can communicate, with other people who also hold those NFTs. Now, if they don't have an NFT, they can also purchase one directly inside the application whenever they want to join a channel. All right, so let's get an overview of exactly how this project is going to work. So basically what's going to happen is a user is going to use their wallet, okay, and they're going to connect, with a wallet like MetaMask with their browser, and they're going to access this website that you saw right here, okay? Let's just see this one right here. Okay, they connect their wallets to the website, and then that website is going to talk directly to a blockchain, okay, which is going to contact the NFT contract that we have created. And if they have, NFTs in their wallet, then they, of course, can view the channels and start chatting. Now, if they haven't, they can purchase the NFTs by minting them from scratch directly on the back end. Okay, and you can see these get minted 1, 2, 3, and they go directly to the user's wallet. And this will also keep track of each channel and that they have access to. Okay, so this is going to be a complete access control solution with these non-fungible tokens. Now, let's talk about the actual chat messages themselves. So, this, first of all, this website, okay, is going to be coded in React.js, and that's going to go, on a web server potentially. Again, this is going to be a hybrid application. It's not completely decentralized. But let's talk about the server itself for the messaging. So the messages are not going to go on the blockchain itself. Okay, that would be very expensive. Every time you want to send a message, it's going to be super slow, not very performant. So we're going to use a server for this, okay? We're going to use specifically socket.io to do real-time communication where we can use WebSockets to send messages. And as soon as you send that, everybody who's a part of the channel will also be able to see those messages provided that they have NFTs and so that you can chat with one another. All right, so let's go ahead and start coding out the project, all right? So I put a link in the description down below to the code for this, okay? And so what you're going to do is copy this, all right? This is a GitHub URL, and you're going to go to your terminal. All right, I need you git clone, and then you're going to paste in this URL here, but then you're going to do --branch, okay, starter_code. All right. And so what that's going to do is it's going to clone this repository, but if you look at that link that I sent you, this is for the master branch, okay? And the master branch contains the final code solution. I don't want to just download the final code solution. We actually want to code this project out. So what we've done is create a separate branch called starter code. Okay, Git organizes its code into things called branches so you can create different versions very easily that you can swap between. And so we're going to use the starter code branch. That's what we did here. Okay, we did git clone dappuniversity, /dappcore --branch starter code. And we're going to enter into that newly created directory like this, say cd dappcore. Okay. And you can see my terminal here is telling me I'm on the starter code branch. So you can also say git branch, and it will tell you which branch you're on. So I'm on the starter code branch. I've verified that that's the exact version that we want. Basically, this has just, essentially got things started so that we have something. We don't have to code everything out from scratch, but we'll still be able to code a significant, the important parts so that you can see how this whole project develops. So once you've done that, we need to just install a couple of the dependencies. Pretty much the only thing that you need for initial setup is Node.js. So we're gonna go to our terminal here and just do node-v. Okay, I'm using version 18.12.0. I highly recommend you use the same version as me. So if you're an experienced developer, you might be able to get by with a different version. But if you're brand new, I highly recommend you can download Node directly from the Node.js website. You can choose the version here, or you can use a Node version manager like N, all right, which is I'm currently using. Make sure you got Node installed, and that's going to let you install all of the other dependencies that you need for this project. So we'll do that like this: say npm install. And whenever that's finished, you should see the success message. You might see some warnings here. Don't worry about that. They're just warnings. And then what we're going to do is go ahead and we're going to see if this worked by just doing npx hardhat test. Okay. And you won't see anything passing. That's fine. All we wanted to do is make sure that we can properly do this hardhat command, and that's going to let us know that everything was set up properly. So if you see a green message here, even if it says 0 passing, that's exactly what you want and expect. And once that's done, you know that everything has worked. All right, so now let's go ahead and start coding out the project. So you want to make sure that you open up your code in a text editor. I'm using Sublime Text. You can use whatever text editor you'd like. But let's take a quick tour through this project, okay? We'll get to some of the major parts later, but really the first thing you understand is we have this package.json file here. Okay, this is where we keep all the dependencies for our project. You can see things like, Hardhat's inside of here. That's the framework we're using to write the smart contracts. We're using, let's see here, React.js for the website. Okay, you'll see that. We're using socket.io for the chat server. Okay. All that stuff's contained inside of here, okay? And we installed those packages whenever we did npm install at the beginning. So the next thing you want to take a look at here is the Hardhat configuration file. All right, so you can see that right here. Basically, this is just the configuration file that points your project to a blockchain. It's got some default settings in there, which you can't quite see right now, but it also specifies the Solidity version that we're using. Okay, this is the version that we'll use to compile our smart contracts. This is the Solidity compiler version. That's exactly what that is. All right, and then the next thing I want to point you to is the contracts directory, because that's exactly what we're going to focus on this section, is creating the smart contract for our blockchain-based Discord clone. Okay, so you've got a contract in here already called Dapp. Okay, this is really just a placeholder. Again, we're on a starter branch that has some stuff put in place for us, but we're going to fill all this out in this coding section. Okay, so we're going to create this Solidity smart contract, and you've got the placeholder here. So at the top, you can see that it's already got the Solidity programming language version. That's how you do it. Pragma Solidity 0.8.9. And then you've got this contract keyword, Dapp, which is the name of the smart contract, and you got these curly braces, and we put all the code for the contract inside of these curly braces. Okay. So let's get a refresher on what we're going to create with this contract, okay? So ultimately, this contract is a non-fungible token contract that acts as the permissions for viewing our Discord server again. Right, so a person's going to connect their wallet to a browser to the website, and then we're going to have an NFT contract that lets people essentially, buy the NFTs if they want to join a specific channel, and it'll give them an NFT so they can access this channel on the Discord clone. Okay, so we need a contract that is a non-fungible token or is an NFT, and then one that actually manages the memberships for each channel that they are a part of. And that's exactly what we're going to create in this section. Now, we're going to use the ERC-721 standard for our non-fungible token, okay? So what is that? Well, basically, ERC-721 is just a specification that describes how NFTs should work so that they're compatible with wallets, with marketplaces, all that type of stuff. And really, it just describes the set of functions that are on it. All right, and what those functions do and the events, all that type of stuff. It just standardizes the behavior and the interface so that it's compatible with lots of different things. Okay, you can see functions like balance of, owner of, transfer from. These are really popular NFT functions that are required by the ERC-721 standards. Basically, the most popular NFTs out there follow this standard, at least most of them do. So, because we're going to use this standard, okay, we don't have to reinvent the wheel on everything. Okay, so we're going to use the Open Zeppelin library, which is a really popular library for creating common smart contracts quickly. OpenZeppelin is a security auditing company in the space. They put out these open source smart contracts. People can use them. They're highly vetted, widely used. So you can see the ERC-721 contracts are in here. And basically, we can just import these into our smart contract and then inherit from them. And that's going to give us a lot of the behavior that we want for free without having to code everything from scratch. Okay, we don't have to sit here and code out a balance of function. We don't have to code out an owner of function, all that type of stuff. We can get it from the library and then just kind of plug it into our smart contract. And then, it'll speed things up a lot. So that's exactly what we're going to do. We're going to import the OpenZeppelin library into this contract first. You can see we've already got it installed inside of our package .json file here. Let's just see here. You can see OpenZeppelin contracts is installed here. So that's going to be in our node modules directory too. Sometimes people ask me where these come from. I'll show you right now. It's really common for people to use the @ prefix on their node modules and puts their stuff at the top, but now everybody does that, so it doesn't really help that much. But let's just see here. OpenZeppelin right here. So @OpenZeppelin, you can see the contracts directory, and then you can see the token directory. You can see ERC-721, ERC-721 .sol. So this is what we want to import. All right. We want to get this ERC-721 contract. You can see it's got like a name, symbol, it's got a constructor function. It's got all this stuff, balance of, owner of, all this stuff, so we don't have to code it out from scratch. Now, you could just like copy and paste that into this file, but that kind of sucks. So we're going to do it a better way, which is just to import it. All right, so Solidity has an import keyword that lets you just pull in stuff from a different file name, including your node modules directory. So it knows to look inside your node modules for this exact file right here. So OpenZeppelin, contracts, token, ERC-721, ERC-721 sol. That's what I just showed you right here. And now we've got that inside of here. All we have to do is inherit from this contract right here. So now we've got this in view inside of our file, and we can just say is ERC-721. All right. And now we have a smart contract that essentially, it just imported all that behavior into our contract here. So let's do one more thing to get this set up and then run a basic test. So inside of here, let's go back and look at our OpenZeppelin contract. Let's just see here. Let's see, OpenZeppelin contracts, token. Sorry, everybody. And then ERC-721.sol. So that's the IERC. Let's look at this. Okay. Notice this has a constructor function. So what is that? Well, a constructor function is a function that's run once and only once. And that's whenever the contract is put on the blockchain or deployed. And what we want to do is fill this in our contract too. This contract has a constructor function, so it wants you to put in the name and the symbol whenever you deploy the contract to the blockchain. So we need to do that as well. So we'll write our constructor function like this. Basically, we'll just say constructor. Okay, we'll pass in a string memory name, and then string memory symbol. Okay, and then we'll pass, we'll just say more code will go here later. All right. But what we want to do is actually pass along this name and symbol to this contract that we're inheriting from. So Solidity has a special syntax for doing that. Basically, what you can do is you can call the constructor of this contract that you're inheriting from like this. Okay, you just say ERC-721. That's the name of the contract. And then you can pass along these arguments that you passed in right here, okay, into this contract. So we'll say name and then symbol. All right, and it should look like that. So constructor, you pass in your name. Symbol, again, these are just strings. That's the data type of the variable that you're passing in. Memory is just the location. And then in order to pass these along to the parent contract, we just call the name of the parent contract here, which is ERC-721, and we pass in that name and symbol. And that will call its constructor function like that, okay? So we can also just move this onto a new line to make it more readable. And then do that, okay? All right, so really quickly, I want to test this behavior out because, we're sitting here coding out Solidity, but we don't know if it actually works. You could do a basic check to see if it compiles. You could go to your terminal and do npx hardhat compile. I think that's the command. I come from a truffle background, so sometimes I forget the hardhat commands. That is correct. So npx hardhat compile worked properly. So hey, at least we don't have any compiler issues. Again, when you're building out the smart contracts, compilation is the first step, just to make sure that your Solidity code doesn't have any issues that won't compile. Okay. So anyways, that works. So now let's go ahead and write a basic test just to make sure that this is working properly. Okay, so I'm going to close down these node modules. We don't really need to look at that anymore. If you go to the test directory, we have a Dapp chord test file in here, okay? So what are tests? So basically, you have this test file over here that's written in JavaScript, okay? So notice these are different programming languages. This is Solidity, this is JavaScript. So it's pretty common to do tests in JavaScript. That's one of the reasons I focus on JavaScript for blockchains. You can do so many things with it. You can write tests, you can write scripts, you can write front-end websites, which we'll do here in a minute. And you really want to write tests for the smart contracts to make sure that they work properly while you're developing them, because it's going to save you a lot of time. This is automating this stuff. Like if you had to go, put this stuff inside a remix and hand test it over and over and over again, it would take you forever. But if you write tests, you can rerun those tests over and over and over again. It saves you lots of time, okay? So additionally, smart contract testing is super important because, smart contract development is so different from, regular development, either a web development or mobile app development or whatever it is, right? Because the cost of mistakes is really high. You can't just push out bug fixes. So you want to measure twice and cut once and make sure that everything worked properly. And testing your smart contracts is really crucial to that process to make sure they're bug free. Because once you put code on a blockchain, it really can't change. So inside of here, what we're going to do is write a basic test. All right. So we're using the Chai assertion library and the Mocha testing framework, which come bundled inside of Hardhat. All right. And what we can do is just write a basic test here that says describe and say deployment. Okay. And then we can pass in a function here. So what we're doing is we're just saying describe Dapp chord, which is the contract, and we're just grouping this into another section here that's just describe deployment. All right. And we write each test example like this. We just specify the behavior. We say like it sets the name. All right. We can say async. Okay. And then what we're going to do inside of here is deploy the contract. Okay. So basically what we're going to do is say const Dapp chord. Okay. Equals await. We're going to use the Ethers.js library for this, which we've got imported already. Say ethers get contract factory. What that's doing is just getting the JavaScript version of this contract, basically. Okay. And then what we're going to do, I'm just going to put it on one pane here so you can see it better. Then what we're going to do is go ahead and deploy that smart contract to the blockchain. So we basically say Dapp chord equals await Dapp chord deploy, and then pass in, let's just give it a name, call it Dapp chord, and then a symbol. Okay. And so again, we're passing in the name and the symbol because this is in the constructor function. This is the function that run whenever the contract's put on the blockchain. We're calling the constructor function whenever we deploy it to the blockchain with this deploy function. So we need to pass in the name and the symbol, which is this right here. Okay. And then what we're going to do is just check that once it's deployed, the name is actually set. And so what that's going to do is basically make sure that, hey, this is actually inheriting from the library. We're able to pass in the name and symbol on deployment, and that it actually, it actually gets those. So we'll just say name and symbol. And so what I'm going to do is I can check the name here. I can say, let's just say let result equals await dappcore.name. And then we can use the expect function inside chai, say expect result to equal dappcore. Okay. And then next we can check the symbol and say result equals await dappcore symbol. And we can just expect, let's just expect results to equal DC. All right. So we deployed the contract here. So I'll just do some comments. And then we'll say fetch name, check name, fetch symbol, check symbol. Okay. And I'll even give those some space so that make a little more sense. So if you want to pause that and copy any of that down, feel free. All right. So now let's go ahead and run the tests, see if it works. So what we're going to do is say npx hardhat tests. All right, it works. So it sets the name and the symbol. So we know that it's working properly. Now, again, this is really just a basic test to make sure that, hey, could we actually wire this thing up? Could we pull in the library? And once you have this test, okay, my code works. That's the value of this test. And once you write it, you don't have to change it. Okay, now, small caveat, we're going to refactor this, which basically just means rewrite the code so that it's better. Okay, because we want to write more tests and we don't want to have to do this every single time. So, for example, we want to say, let's just write, really, when you're doing a test, most of the time you just want to check for one thing at a time. So like we want to do, I'm just going to copy this and put it here. And so like this is going to be just sets the name. All right. And then this one's just going to be sets the symbol. We only want to do check the name in this one, symbol on this one. But, we can say fetch name and then fetch symbol. So let's take the symbol out of this one. And then let's take the name out of this one. Okay. And then we can say let result. Okay. And then we can run the test again. All right. Now you can see that each test is on a different, example. So it sets the name, check. It sets the symbol, check. It's nice to see both of those in their own test rather than just it sets the name and symbol. Because if one of these failed, you'd have to dig in and figure out which one was failing. All right. So you can see we have some duplication here, like we're deploying the contract inside of each test example. We don't want to do that either. So what we can do is use a before each function. So we can say before each is async. All right. And then pass in this. Okay. And what we can do is move this up here. So we can put this here. Excuse me. All right. And then what we want to do is, let's say let dappcore up here. So we can check it throughout here. And let's take this out. And then let's, all right, it looks like it's still working. So you see what I did here? Basically, we were calling this line inside of every single test example, and that's duplication, and it kind of sucks. So what we do is use this before each function, which is going to run before each of these test examples, okay? And so all it does is basically get the contract and deploy it to the blockchain, so we've got a fresh copy, okay? Now, we can also refactor this so that we're not just checking name and symbol. We can put this up here. We can say const name and symbol. We can save these as constants up here, okay? And we can pass in, name and then symbol. Okay, and let's just run the test real quick to make sure it passes, that it actually took those. All right, and that's the nice thing about tests. You can just change things and run them to see if it still works. And what we can do is then pass in the name here and symbol here. Okay. And boom. So that way you don't have duplication. You just define the name and symbol here, you deploy it here, you check it here. All right. So let's go ahead and do one more thing before we move on here. The last thing I want to do with this is set an owner for the smart contract. Again, so in our thing here, we want somebody to be able to receive money. Okay. So let's say somebody purchases the NFTs with Ether, that's Ethereum cryptocurrency. Whenever they mint them to join the Discord server, we want to get paid for that, okay? And we want the owner of the smart contract or the person who created it to be the one who receives the money. So we need to define that person. We're going to call them an owner, okay? So what we're going to do is basically set an owner up here, okay? So we're going to use a state variable for this. So a state variable is essentially a variable that's going to get written to the blockchain. It's going to get saved on chain. Okay, it's a variable that belongs to the entire smart contract, so you can reference it wherever you want to, not just inside specific functions as local variables. So we can define a state variable like this. We just say address public owner. Okay, so this is going to be the person who owns the smart contract. So let's check out the syntax here. Address is the data type. Okay, so an address is like an Ethereum address, like your wallet address. Like, an example is 0xabc123 blah 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 kf1. Okay, like I'm abbreviating that, right? They're really long, but that's kind of like what an address looks like. But that's what the address data type is. It's basically a wallet address. Okay, Solidity is a statically typed language, which means that you have to define the data type, and it's not going to change whenever you do that for this variable. So public is the visibility, which means you're going to be able to read this variable outside of the smart contract. And that also means Solidity is going to give us a special function so that we can read this variable outside the smart contract. We can basically just call Dapp cord owner, and it'll tell us the address of the person who owns it, right? So this is just defining the variable. We also want to set it. So when do we want to set it? Well, we want to set it in here whenever the contract is put on the blockchain. Basically, we're going to take the owner as the person who's deploying the contract. So the developer that puts it on chain, that's going to be the owner. So how do we get that person? Well, we do this. Okay, so what is this? Well, basically, we're assigning this owner here, so we can reference this variable value inside this constructor function, and then we use this equal sign to assign it to message.sender. So what does that mean? Well, message is a global variable inside Solidity, which means it's available everywhere inside of any Solidity contract, okay? And it has several properties on it. One of them is sender. And sender is the person essentially who's calling this function, in this case, the deployer. So it's an address. And so basically we can take this address and assign it to the owner, and we save it as address type in the public, owner variable, and we'll be able to reference that out of the smart contract. And we'll, of course, reference the owner in a couple of different places for the smart contract, okay? So let's go ahead and check for that. Basically what we're going to do is have a test here. All right, after it sets the symbol, that just does this. It sets the owner. So basically, we'll say const result equals await dappcore.owner. That's the function I was talking about we get for free. We expect result to equal deployer.address. Okay, so we want to save the deployer. All right, we do that like this. Basically, we can get some signers from Ethers.js. Basically, these are the wallets that are connected to Ethers with Hardhat. Basically, we just say await Ethers get signers, okay? And basically what that's going to do is return an array of all of the accounts that are connected to Hardhat tests, okay? So we can, basically break those out like this. We can say deployer and then user. We can set up two different accounts, okay? And then essentially we can, create variables for those up here like this. And then that's going to save each one to an array. So this gets kind of confusing sometimes. Basically, understand that Ethers get signers returns an array of signer objects, not addresses themselves. They're objects, but it's an array. And if you want to pick out individual items from this array, you can just say deployer user equals await Ethers get signers, and it's going to do it. It's going to assign these variables to the first two items. It'd be the same thing as saying like, deployer equals, signers 0, and then like user equals signers 1, if you had saved this result to a signers variable. So it's the same thing, it's just a shortcut. Okay. So anyways, we got a deployer. And so now what we're going to do is just check that the owner is equal to deployer address. You have to call .address on here because it returns a signer object. If you want to actually pluck the address itself, you need to do this. All right. Let's see if the test passes. Yep. Awesome. So it sets the name, the symbol, and the owner. All right. So now that we've got the basics set up, let's continue on with developing out our smart contract. Okay. So first of all, what we want to do is take a look at this. Basically, someone needs an NFT anytime they want to join a Discord channel. Okay. So what we're going to do is basically set up a way to save all the Discord channels inside of our NFT smart contract. Okay. So what we're going to do is have a function inside of here called create channel. Okay, so you can create a Solidity function just like this. You give it the function keyword, you give it the function name. All right, we're going to call it create channel. That's just a name we came up with. And then you can pass any arguments inside of these parentheses here. And of course, you put all the code for the function body inside of these curly braces. I'll just say code goes here. Okay. And so we're going to take 2 arguments for this function, which are just parameters that you can pass in whenever you call the function. So we'll say string memory name, and then string uint 256 costs. Okay. So basically string is a data type string. It just looks like, anything inside of quotation marks like foo bar baz. Okay. And then a uint 256 is what's called an unsigned integer in Solidity. It's just a number 1, 2, 3 with no sign. So it's not negative. Okay. A negative integer would be a sign is a minus sign. Okay, so this has no sign, which means it's positive. It's an integer. Okay, it doesn't have decimal places. All right, and it can be 0. So anyways, the string name and the cost, this is the name of the channel. It's what it sounds like. And cost is going to be the cost of cryptocurrency to join the channel. And that's going to be paid in Ether. They're going to pay in ETH. They're going to get NFT. And they're going to create the channel whenever they're going to join the channel whenever they do that. Okay, so this is not the cost to create the channel. It's the cost to join the channel. So we want to call this, we give this function a visibility, which is going to be public, which basically means you can call this function outside the smart contract, maybe from a website, for example, or with your wallet. It doesn't mean that you can only call it inside the smart contract from another function. Okay, so what we're going to do inside of here is we're going to save a new channel. We're going to create one. So in order to do that, we need to model a channel inside Solidity. So Solidity has something called structs, which lets us create our own data types however we want to, and we can define them with a struct keyword like this. We can say struct channel, all right? And what that does is we create this new object, so to speak. That's not really a technical term. I'm trying to give you layman's terms to understand what this is doing. It's just this new structure, this new data structure, new data type called channel that we defined out of nowhere, and we give it some properties, okay? So one property is going to be an ID. So we'll say uint 256 ID. And then string name, and then uint 256 cost. So think about this in really simple terms. Like we get to create this arbitrary data structure called channel, and we just give it some properties like an ID. You can think about an ID as just like a unique identifier, 1, 2, 3, 4, 5, 6, 7, 8, 9. Which channel is it? Hey, it's channel 10. Hey, it's channel 25. Hey, it's channel 50, right? That's how you think about this. The name, pretty obvious. What's the name? New developers, welcome channel. General, Q&A channel, right? And then cost is how much does it cost to join that channel? Does it cost 1 Ether to join? Does it cost 0.1 Ether to join? Does it cost 50 Ether to join, right? Those are different properties that are on this channel, okay? So now this just defines how a channel works. It doesn't actually create a channel. So we're going to create one like this. Basically, inside the function, we'll create a new channel. We'll say channel, and then we'll pass in an ID, let's just say 1 for now. And then the name is going to be the name passed in from here. And then the cost is going to be the cost passed in from here. So that's how we create a channel. Here's defining how the channel works. Here's creating a new one inside the function call. Okay. Now, where do we put that channel whenever we've created? Because all we've done is just created a new channel in memory. We haven't actually saved it to the blockchain. Okay. So we're going to save it to the blockchain with something called a mapping. All right. So a mapping looks like this. Okay. So what did I just do here? Well, I created a mapping. A mapping is a key value pair. Okay. So what is a key value pair? Let me just show you. Basically, it's a way to store information where you have a unique key, all right, that maps to one and only one value. Okay, so let me just pull this up here. This is a pretty good example. So you can see this on Stack Overflow. So here's a key value pair on a table. You have a key, first name, value is bugs, last name, value is bunny, location, value is earth. So this is an example where you have a key that corresponds to one and only one value. All right. So first name, you can't have two first names. I guess you technically could, but in this case, let's say you can only have, like if you had a hyphenated name is what I mean. But like you only have one unique first name. Like you don't change your name. Okay. So it's always bugs. Last name, let's just say for example's sake, you can never change your last name, right? It's permanent. So then it corresponds to one and only thing. Okay. So similarly, we can do that inside Solidity with this. Basically, we can give it a key, which is going to be the ID. That's just going to be the number, like, hey, which channel is it? 1, 2, 3, 4, 5. And then the value is going to be the actual channel itself, which we put in here. So you define the mapping by giving the data type of the key. In this case, it's an unsigned integer. It's just a non-negative number. Okay, that's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 blah. And then the value that it corresponds to is going to be the channel, which we created right here. And then we just saved that mapping to a variable called channels. Okay, we just gave it an arbitrary name here. And then we made it public so we can read it outside of the smart contract. But even though it's public, we can also read it and write to it inside the smart contract as well. Okay. So we can take this channel that we just created and we can save the mapping to it like this. It's pretty simple. All we do is say channels 1 equals channels. Equals this new channel that we created. So you save stuff to a mapping by giving it the mapping name and then using brackets to pass in the ID that you want to save it to, or the key, I should say. The key in this case is just 1 because it's channel 1. We just give an ID and we say, okay, so channel 1 is going to be equal to, that's the assignment, this new channel that we just created right here. Okay. So that's basically how you do that. So, yeah, that's the gist. That's how you create a channel. Channels 1 is equal to this new channel. Now, there's one final problem with this, which is every single time that we call this function, even if we give it a new channel and name and cost, it's going to create a new channel, but it's going to overwrite channel 1 because we're just saying, hey, create channel 1 every time. What we want to do is create channel 1 the first time we call this function. The second time we want to create channel 2, channel 3, channel 4, blah, 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 and then increment that value in an intelligent way every single time we call this function. So what we're going to do here is create a state variable, all right, called total channels. We'll call uint public total channels right here. This is a uint 256, just like we saw right here, It's just a number, a non-negative number. Without decimal places, that can also be 0. And what we're going to do is say, total channels. We're going to reference that value. All right, the first time that we call this function, it's going to be 0. Okay, it's basically like whenever you do this state variable, the default value is 0. So you could specify that here, or if you don't do that, it's just going to default to 0. So the first time we call it is 0. So what we can do is say total channels equals total channels, plus 1, okay? And then you can take this total channels, which is now going to be 1 the first time we call it, and then you can replace the channel ID with total channels, and then you can replace the key here. All right, and so now basically every time we call the function, it's going to add 1 to it, and it will intelligently increment the channel count and just create channel 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, et cetera, et cetera. Okay. Now, what the last thing I'm going to do is basically take this function and refactor this, because there's a better way to do this in Solidity. Instead of writing this saying total channels equals total channels plus 1, you can just take total channels and just do plus plus, and that will add 1 to it. All right, that's a shortcut inside Solidity. You don't even have to use the assignment. You just take the variable value. This is called the increment operator, which just adds 1 to this number and saves it. Okay, and then now we can do total channels equals channel. All right. All right, so now inside of our test, what we're going to do is check for this. So we're going to collapse this so that I can have some more space. Okay, I'm going to add some space at the bottom. And what we're going to do is have a describe here that says describe joining channels. And actually, let's change that to creating channels. Sorry, we'll describe joining in a minute. Yeah, okay. And so what we can do is basically, in our before each up here, we can actually create a channel, okay? So what we can do is basically create a channel like this. Say create a channel. All right. And then I'm going to say const transaction equals await Dapp cord connect deployer. All right. And then say create channel. Pass in a name. We'll say general. And then let's pass in a cost tokens 1. All right. And then let's do this. Say await transaction wait. All right. I'm going to pause that and check it. Let's just run the test to make sure nothing broke, and then I'll explain all that code. All right. So it still works. Now we're not checking for creating channels, but we just wanted to do this in our setup step to make sure it didn't break anything. Okay. So let's explain what happens. So what we're doing is we're calling the create channel function on this Dapp cord smart contract. But when we do that, we have to specify who's calling the function. So we do Dapp cord connect, which basically connects a signer, in this case, the deployer or an account, if you can think about it that way, to the Dapp cord contract. Because what we're doing is we're calling a function. We have to use our private key to sign that function call. That's a transaction that's being submitted to the blockchain. And so we have to tell it who's doing it, okay? Because it's a write function. You have to pay gas to do that. And it's going to deduct the gas from the deployer's wallet. So basically, you have to connect the deployer to the contract, so you can call this create channel function, okay? So we call create channel, pass in the name, all right, because it requires a name, right? Here's the name, create channel. And then the cost, we're going to say cost 1 Ether, okay? And so we're just passing in 1 to this tokens function. Now, let me explain why we have to use this function in the first place, which we imported here, okay? So again, we're using this thing uint256 all throughout our smart contract. That's because Solidity doesn't deal with decimal places. Anytime you want to deal with something that has whole number, anytime you want to deal with something that has with decimals, you have to just express it as a much larger value and then basically convert it to decimal places later. So if you want to write 1 Ether as the cost, let's say you want 1 Ether, you can't just pass in 1 to the smart contract, because you have to tell it how many. It doesn't know how to deal with decimal places after it. So what you have to do is express it in the way value. Okay, so basically, what is way? Well, way is like a penny in the Ether ecosystem or the Ethereum ecosystem. What I mean by that? Well, think about the US dollar. The US dollar has, is made up of cents. Like cents are the smallest unit of a dollar. So a dollar is equal to 100 cents. All right. So I'm just going to do this and say $1 equals 100 cents. So 1 Ether is equal to this many way. Okay. So is equal to okay. So basically there's 18 zeros after the decimal place. That's how you can think about it for, is how you can think about it for Ether. So you can see that on a website like Ether Converter. Okay. You can basically you can say, one ether is equal to this many Gwei. And if you're trying to go backwards, you can do that. You see the Gwei value. Okay, that's why we do that. So basically you could just write, this. Though that sucks, right? It absolutely sucks. Hard to read that. You have to go and count every single decimal. And every time I write that out, I'm literally counting in my head how many zeros I'm putting in. So that's a pain in the butt. So we use this tokens function to convert 1 to that big, long number that you saw right there, okay? All right, so anyways, that's working. I need to explain that part because that's a kind of a gotcha for most new people. And so for creating channels, what we're going to do is just create an example inside of here that it says it returns the total channels. So say it return total channels. Basically, we're saying const result equals await Dapp core total channels, which is this function right here. All right. And then once we've created the one here, it should return the number 1. Okay. Expect result to be equal 1. And then we're going to say it returns the channel attributes. So basically, you can jump in there and say const channel equals await Dapp core get channels 1. All right, you can say get channel, which is calling this function that we just created. All right, and you get the name. Well, actually, we don't have the get channel function yet. Let's go ahead and create it. Okay, so what we're gonna do is once we've done create channel, we can do get channel like this. Basically, we just do function get channel, pass in the ID. All right, it's called public. It's view, which means it's a read-only function. Okay, it doesn't modify the state. But it can read from the state and do returns a channel from memory. Okay, and we just pass in the ID, channel ID. All right, and then inside of here, we can just say, we get that channel with the function, pass in 1, and say channel ID to be equal 1, expect channel name to be equal general, and expect cost to be equal to tokens 1 or 1 ether. So that's all our tests. I'll let you pause this if you want to copy this down, or you can get it from the final code solution. And I'll go back to the smart contract in a second to see that other function that we quickly kind of threw in there. So I'll pause this first. All right, now if you want to check out this and pause the video, here's the get channel function. All right, so let's run the test, make sure it passes. All right, boom, it works. All right, now there's one more thing I want to do on this create channel functionality. Again, we have this owner of the smart contract, and really we don't want anybody to create channels. You can kind of think about the owner like being a moderator for the Discord as well. So we only want them to create the channels, okay? So how do we do that? Well, we can use a function in Solidity called require. Okay, so require, what it does essentially is it checks that a statement is true or false. So if I said require if I said require true, basically nothing about this function is going to change, okay? And so what I can do is pass in expressions inside of here, like say 1 plus 1 equals 2, all right? That's a true statement. 1 plus 1 does equal 2. And so this expression will evaluate to true. And because it evaluated to true, everything in this function, like the function will keep running after this, okay? And we can actually create channel. But if I said 1 plus 1 equals 3, that's not true, all right? And what would happen is the function would stop at this line and nothing after this would run, and the function would revert and the transaction would fail, okay? So essentially, require, what it does is it puts a check in here that says, hey, require that this thing that I'm checking for right here is true before you do any of this other stuff. So in this case, what we can do is we can require that, let's see, message.sender, all right, the person who's calling this create channel function is equal to the owner, all right? So message.sender equals the owner, the person who created the smart contract. If that person is, if the owner is calling this function, then do all this stuff. If it's not the owner, then basically just revert the entire transaction and don't let this person do this, okay? So we can just run the test to see if it still passes. It should still pass. Yeah, it still passes. That's because inside of the test here, we're actually connecting to the Dapp core contract with the deployer who is the owner. And you could write a separate test to check for this, but just for the sake of time, I'm not going to do that. All right. And so that checks for the message sender equals the owner. Now, what we can do is make this better. we can use something called a modifier inside Solidity. So let's say we wanted to do this in multiple functions. We could not have to repeat ourselves so much. We can create something called a modifier up here, where we can basically say modifier only owner. And what we can do is basically copy this and put it inside of here. Run the function body, and then apply this to our function just like this. Okay, and then if I run the tests, it should still pass. Awesome, still passes. So what did I just do? Well, I created this thing called a modifier, and what a modifier is, it's just something that modifies the behavior of a function. So what this says is whenever you apply this to a function, you run this require statement before all the other code in the function, okay? So people ask me, what does this little underscore mean right here? That represents the function body, and what it's saying is do this before you do everything else. You can put it after, you can put stuff before and after. It lets you specify it however you want to, but in this case, we're saying before you do anything inside that function, check this first. Make sure that only the owner can call this function, and then we take this modifier and we just apply it to our function like this. Here's the function visibility. Here's the modifier. All right. And so what we can do is we can use that on another function at the end, which we'll get to momentarily. All right. So the last thing that we want to do, well, mostly the last thing we want to do here is we want to mint NFTs. So somebody has a NFT, we can check that so they can join a channel, right? We've created the channels. Now we want them to join a channel. And when they join a channel, basically they're going to mint an NFT every single time they do that. So we can call a mint function, which basically creates their channel access or their NFT from scratch and then sends it to their wallet, okay? And that's exactly what we're going to do right now. So basically, we're going to create a function here, all right, called mint, okay? And then inside this function, we're going to basically join channel and then mint NFT. All right, that's exactly what's going to happen. So let's fill this function out. Basically, what we're going to do is say uint 256 ID, all right? And then basically that's going to keep track of the channel that they're joining. That's the whole ID. That's the basically the channel ID, so I can think about it. And say public payable. So payable basically means that they can send in cryptocurrency with this transaction because they have to pay in order to get an NFT. So the payable crypto is going to be Ether itself, or if you're deploying this to the EVM compatible chain, the gas token for that chain. Okay. So inside of here, we're going to use our Open Zeppelin library, all right, which we've imported here. And if I show you inside of that, node modules, open contracts, Open Zeppelin, IRC 721, basically we've got a function in here called safe mint, all right? And so what that does is creates a token. It mints one from scratch. Basically, it gives it the wallet. You say who you're going to send it to, basically the wallet address, the token ID, and then any data that you want to have associated with that, okay? So we can call this safe mint function from their contract like this, okay? And then we can say message.sender. Okay, that's the person who's minting the NFT. All right, that's the wallet it's going to go to. And then basically, we can essentially give it an ID. For now, we're just going to say 1. We'll fill this in a minute. So, but that's the functionality to mint the NFT. All right. So, how do we basically get this number? Well, remember we hard-coded that before with channels. So what we want to do is keep track of the total supply of NFTs. All right. So at the top, what we're going to do is create a state variable called total supply. That's going to be just an unsigned integer. That's going to start at 0. But then every time we mint an NFT, we can just do total supply and then increase it by 1. All right. And just like we did with the channels, and then pass in total supply right here. All right. And this, I guess that's kind of all the same. I'm just going to take these comments out. But anyways, we're minting the NFT here. And then we need to join a channel. All right. So in order to join a channel, what we're going to do is just like we have a mapping of the channels, all the channels available, what we're going to do is create a channel, a mapping that says who's joined channels, okay? But this is going to be a nested mapping, and it's going to be kind of confusing. So I'm going to explain it, all right? I'm going to toss this in here. It looks kind of confusing, but let's talk about what it is. So this is a nested mapping, all right? It is a mapping that contains a mapping. Okay, it's two-dimensional if you want to think about it that way. So what we do is use a mapping keyword, all right, that takes a key of an unsigned integer, all right, and that's going to be essentially the channel, all right. So say for channel 1, what we're going to do is we're going to turn another mapping that's all of the addresses of the people who have joined that channel. And basically, the key is going to be the address, and a Boolean value is going to be true or false. So basically, how we could look at this is say like, hey, in channel 1, let's check for this person's address and return true or false. Are they a part of this channel? Okay. Or we say, channel 2, pass in somebody else's address, and it might return false, so they're not a part of this channel. And basically say public has joined. Now, by default, this is going to be false. So anybody who has not joined a channel, we check for the address, and then they haven't joined yet, it's going to return false automatically. So what we want to do is set that to true so that they can join the channel. All right. And we do that like this. We just say has joined. All right. We give it the first key, which is the channel ID. All right. So this is the ID that's getting passed in here from the function call. And then we just say message.sender. All right. Which is the person who's calling the function. And we say true. Okay. That's how you join the channel. It's pretty straightforward. All right. So now they're going to mint an NFT. It's going to go to their wallet, and they're going to join the channel. Now, inside of the test, let's go ahead and check for this stuff. Let's just say it joins the user. I'm going to go ahead and toss this test in there so that you can see how it works. You can grab the final code solution if you want to. All right, so it says describe joining channels, and you can also pause the video if you want to copy this down by hand. Say joining channels, so const ID is going to be equal 1. Amount they're going to pay is Ethers utils parth ether 1 ether, okay. Do it before each, which basically is going to call Dapp core connect user, just like we did before. We're going to call the mint function we just created, passing the ID. Now this thing right here, value, is the amount of cryptocurrency that we're going to send in with the transaction. In this case, it's just going to be 1 ether, okay? And so what we do is check that it joins the user. So we say, const result equals await Dapp core has joined, user address, expected to equal true. It increases total supply. So we get total supply should equal to the ID. And then it updates the contract balance to make sure that it received the ether. So we say result equals await ethers provider, get balance, Dapp core address. Expect result to be equal to amount. All right, let's save that. Let's run the test, make sure that it passes. And boom, it passes. All right, so I'll let you pause the video here if you want to copy this down by hand, or you could, grab it from the final code solution if you want to. All right, so there's a couple last little things we want to add to this. Okay, we want to add some require function calls to make sure that everything works properly in this function. Again, you saw this a second ago when we did the only owner. We require that owners equals message.sender. So we don't need that because we want anybody to be able to mint it, but we want to have a couple things. So first, we want to make sure that when they're minting this, the ID that they're passing in does not equal 0. So bang equals 0 is important. All right. We want to make sure that the ID is less than or equal to the total channels, because you don't want to create some ID of a channel that doesn't exist. So it can't be 0 and it can't be more than the total channels. All right. We want to make sure they can't join a channel twice. Okay, so if they have joined the channel already, it is equal to false. All right, so basically we want to make sure it's false before they join it. And then last, we want to make sure that the amount of cryptocurrency they're sending in, message.value, this is message.sender, this is message.value, that's the amount of crypto that's getting sent in, is greater than or equal to the actual cost of the channel. So they're actually sending in the correct amount of ether. All right. So you can write tests for those specific things as an exercise if you want to, But for now, I'm just going to run the test and make sure that it passes. All right, it passes. So you can pause the video if you want to copy down those things, or you can grab them from the final code solution. All right, now there's one last thing that we want to do before we wrap up this smart contract. So right now, we've created channels. We let people join the channels. They're paying to get these NFTs every time they want to get it. And then what we want to do is actually send the money to the developer or the owner in this case. Now, in this workflow, when somebody sends in money to join the channel, the cryptocurrency is getting held in the smart contract, okay? It just lives inside the contract. What we want to do is have the owner be able to withdraw it from the contract, okay? So I'm going to have one final function here that I toss in there. You can grab this in the final code solution, or you can just copy this down by hand. I'll let you pause it, but let's explain how it works. So we have a function called withdraw. All right, it's public, so it can be called outside the contract, but only the owner can call it. That's important. Okay, we want only the owner to be able to withdraw the funds. So what we do is say owner.call, and so what call does inside Solidity is it just sends a message to the owner, okay? And for any message call, you can send in metadata just like any other function call. You can specify the value. So basically, you can send in money with this call to the owner. So message.value is going to be the address of this balance. So basically, you can say address this. This is the smart contract that we're coding inside of. Address, just make sure that it's an address. And then .balance gets the actual Ether balance of the entire contract. And we just say send all this money to the owner. And we like do this call here, and we're just passing in an empty string because we're not actually sending anything else with this message. We're just sending in value. And then this returns this tuple, which we can turn in. We can get the first part of it, which is just the success, true or false. This also got data that you can pull out here, but we just get the first thing is success, and we should require that they actually received it. This looks kind of weird. You could use a transfer function, but I'm seeing more and more Solidity developers use this for security purposes. So I'm going to leave you all with that strategy. Okay. So anyways, let's do a quick test for this. Again, you can grab this from the code solution if you want to, or you can copy it down by hand after you pause the video. So we're going to say describe withdrawing. All right. So basically, we're just going to set this up, say ID equals 1, amount is 10 Ether, balance before, and basically what we're going to do is basically get the deployer's address as the balance before. We're going to mint an NFT with that amount, and then we're going to withdraw those funds, okay? So basically, it checks the owner balance, checks the balance after, and make sure that it's greater than the balance before, and it updates the contract balance and make sure that everything's been drained. Basically, the final contract balance should be 0. All right, let's do that. Save, go to the terminal, npx hardhat test, and boom, it passes. All right, so now we have finished the smart contract, okay? So the next thing we want to do is actually take what we've written here and put it on a blockchain so that we can start developing our app, okay? So I'm going to close this down, and I'm going to open up our file browser here, okay? And I'm going to look at this file called scripts deploy. So Hardhat lets you write your own scripts, do whatever you want to, but we want to use this specific script here to deploy the contract or put it on the blockchain. So we've got a placeholder here that basically just has our tokens helper has this async function called main, and then we call the function. And basically what we want to do is add deployment here. So basically we want to, get the smart contracts in JavaScript and then put them on the blockchain. So we're going to write a routine that looks very similar to what we did in here. Okay. So you can see that we got the Dapp core, Ethers get contract factory. We set up the signers, all that type of stuff. And then we created a channel. All right. We're going to do this very similar type of stuff inside of our deployment script. All right. You've seen a lot of this stuff before. So what we're going to do is we're going to set up signers. We're going to do the setup at the top. All right. So set up accounts and variables. We're going to say deployer equals await Ethers get signers. That's just like we did right here, but we're not going to worry about the user. We just want the deployer. All right. We want the name, Dapp core, and the symbol DC. All right. Just like we did right here. All right. It's the same thing. And then we're going to deploy the contract. All right. So const Dapp cord equals await ethers get contract factory Dapp cord. Const Dapp cord equals await Dapp cord deployed name and symbol. We just pass those in. And then we do await Dapp cord deployed. All right. That's the exact same thing we did right here. All right. With a slight difference. Instead of doing deploy, we're saying await Dapp cord deployed after. Okay, so we do deploy, which we did here, but then we do await Dapp cord deployed because we actually want to wait for the deployment to finish before we actually do more stuff. Okay, so we can log that to the console like this. We can say console log deployed Dapp cord contract at, and then we can pass in the Dapp cord address. Okay. And then we can create some channels. All right. So we're going to create 3 channels in this case. I'm going to just kill that test. I'm going to say create 3 channels. And what we're going to do is, call the create channel function, but we're going to do it 3 times. So we're going to do it in a loop. All right. So we can basically use a for loop inside JavaScript. So we can basically write this. We can basically say for var I equals 0. So let me explain this for loop in JavaScript because it can be confusing people sometimes. So what is a loop? A loop is just something that says, hey, do a certain routine in code over and over again. So I'll say code goes here, channel creation. So basically what we want to do is create a channel 3 times. And basically we can write a loop that does this 3 times. So loop just does something over and over and over again until you tell it to stop. So we give it the parameters for the loop right here. Basically, we create a new variable called I, and we set it to 0. And basically we say, okay, here's your variable I. It's called an iterator. We set it to 0. And then basically, as long as I is less than equal to 3, then run this code inside of here. So in this case, I is 0. It's less than 3. That's true. Run this code. All right. And then after this code finishes, add 1 to I. Okay. And the next time this code runs, I is going to be equal to 1. Is I less than 3? It's true. Go ahead and run this code. Then increment to I is going to be equal to 2. Do that. And then the last time, is it going to be less than 3 once this is equal to 3? No. So it does not run this anymore and the loop stops. Okay. So that's how that works. All right. And so how do we create a channel? Well, we're going to create some parameters here. We're going to do this. We're going to create some variables, channel names, general, intro, jobs. This will just be arrays, and then costs, tokens 1, tokens 0, tokens 0.25. So this will be free channel for the intro channel. General will cost 1 ether, and then jobs will be 0.25 ether. Okay, this is just the Discord channel names. And then inside of here, we're going to do this. Okay. I'm going to zoom out. So basically, we're going to say transaction equals await Dapp core connect deployer, create channel. We do channel names I. So basically, every time this runs, this is going to be 0. So channel name 0. The first time it's going to get the general channel, and the cost is going to get from the costs. Costs I is 0. It's the first one, so tokens 1. And then we wait for that to finish, and we console log that channel is created. Second time, it'll do the intro here, and then the cost is 0 here. And the third time, it'll get the jobs name here, and then the jobs cost from here, pass it in here, and it'll log it to the console. Okay. So that's it. That's our deployment script. That's going to put these contracts in the blockchain, and it's going to create the channels for us. And then that way, whenever we boot up our website, we'll have some data already in the smart contract, which is awesome. So the final step on this is to actually run the deployment. So we're going to open up a new tab here. We're going to go ahead and start our blockchain. So we're going to run the Hardhat node. We can do npx Hardhat node. All right, now we've got a development blockchain running that has, 20 different accounts, all with 10,000 fake ether in them. You can see the public keys and the private keys, the account addresses and the private keys. Definitely don't use these accounts to store any real money. Anybody who's ever started Hardhat before could steal that money because they all use the same accounts unless you change the mnemonic. Don't use this seed phrase. Okay. All right. Don't use the private keys, et cetera, et cetera. Okay. So anyways, that's our blockchain running. Now we need to run the script, and you can do like this. npx hardhat run. Okay, I'm going to pull this up so you can see it. Deploy scripts, deploy.js -- network localhost. You got to make sure you put the localhost flag in there. Okay, awesome. So deploy Dapp cord contract to this. You can see the address is logged to the console here. You say create a text channel general. All right, text channel intro and then jobs. And you can see that was, these transactions actually went through here on the, on our Hardhat node. Okay. So the last thing you want to do to clamp the deployment is basically take this thing and go to source directory and look at the config.json and make sure that your address, matches what's here. So whatever this console logged address here is, take this and paste it inside of here. It should be the exact same. Sometimes it'll change, but like most of the time, Hardhat uses the exact same contracts every time you deploy in order. So if you deploy 2 contracts, the first and second addresses usually be the same. I've seen it occasionally change. I don't know if that's just node versions or something, but typically speaking, this should be the same. But you want to double check and make sure in your config.json file that your Dapp cord address is the exact same as what was deployed and logged to the console there. And that inside of here, you take your artifacts and go to the contracts and go to dappcord.sol and look at this JSON file and then get your ABI. So ABI is the abstract binary interface. This is essentially just describes how the contract works. So it describes the interface so that you can create a JavaScript version of it. You're going to want to collapse this and then take it, copy what's in the array only, okay? And then make sure that that is the same here inside your ABIs, your dappcord.json. So as long as you didn't make any code changes, this should be the exact same thing. As long as you have the exact code that's in the final code solution, then this shouldn't change. But if you changed anything, you want to make sure and update whatever ABI was in here into this ABI. Again, these are the things that we need to build out the front-end website, which we'll do next, but I just wanted to cover that deployment step just to make sure that once you've deployed and every single time you deploy, you need to make sure that these things are actually updated. Because the last thing you want to do is make a change and then not tell your front end about it, and you're stuck wondering why your project doesn't work. So I wanted to include that in the section, and that's it for this part. All right, so now let's start coding out the front end for the project, okay? So, up to this point, we've created the smart contracts, we've put it on the blockchain, so you need to make sure you got your blockchain running here, okay? And then you also want to open a new terminal tab here, and we want to go ahead and start our front end server, okay? So we're going to create a React application. There's already some placeholder code in there, and we can start that reapplication like this. We can say npm run start, and you should see your app start in a new window here. All right, so now that this is loaded up, you can see we got our basic website code here. Okay, this doesn't look like much. Don't worry, we're going to fix all this and make it look more like our mock-up. So I took a screenshot of the final code solution. You can see what it's going to eventually look like, and we just got to make it look a little bit more like that, okay? So our first step is, of course, make sure you have MetaMask installed. This is the browser extension that's going to turn our web browser into a blockchain browser. Okay, most web browsers don't support connectivity to the blockchain out of the box. You need to have a special extension for it. That's what MetaMask does. So what you're going to do is open MetaMask and make sure it connects to your Hardhat blockchain, okay? So if you've already done Hardhat before, you should have a Hardhat option saved here to your network dropdown. Maybe you're on the Ethereum mainnet. You want to switch to your Hardhat connection. But if you don't, you've never connected to Hardhat before, you need to click Add Network, okay? And then what you can do is, see if they have a Hardhat one. They don't. So what you're going to do is add network manually. You can call it Hardhat, okay? For the RPC URL, you're going to just go to your Hardhat blockchain, your node here, okay? And you're going to essentially find this here, put it in here. Okay, the chain ID, you can see it in your project. The chain ID is in your config file, okay? So source config.json, this is the chain ID. All right, and the currency symbol is ETH, and the block explorer doesn't exist. So you can click save. I've already done this. It's not going to let me add this, but that's how you add Hardhat. And once you've done it, okay, you can just go up here and select Hardhat in the network dropdown. All right, next you're going to need to import your accounts from Hardhat. So you can see these accounts. You can just copy the private key here. You can go like this and go to import account. All right, you're going to paste the private key in there. I've already done it, so it's not going to let me do it again. But I did that, and then I'd go to account details, and then I usually rename the account right here. I call it Hardhat number 0 because Hardhat accounts are 0-based index, so 0, 1, 2, 3, 4, 5, etc., etc. And then I can see easily which Hardhat account it is with a label right here. Now, what I would do is go ahead and repeat that step for multiple accounts. I've done it for 6 total Hardhat accounts, and that lets me just really quickly switch back and forth between these accounts whenever I'm developing stuff. But at a minimum, you need to import the first account here. Now, the nice thing about the Hardhat node is every time you restart the blockchain, these same accounts will exist. Okay, so you don't have to keep adding them to MetaMask. All right. But that's the first step. Make sure you have MetaMask installed. Make sure you're connected to Hardhat, and make sure that you are, got your accounts imported. So now what we're going to do is go ahead and do the first step, which essentially is to connect our wallet to the application. You can see there's a thing here where it's got the header, it's got the name, and then your wallet address with a connect button. We want to do that before we do anything else. But in order to do that, we're going to go ahead into our front end application. Okay, so all our blockchain stuff's in the contracts directory, but all of our front end stuff is in this source directory here. Okay, so you can see source app.js. All right, this is the main file for our front end app. So if you look inside here, this is all JavaScript. This is React.js. Okay, so if you're not familiar with React, it's a front end framework for building user interfaces so that you don't do everything yourself. You can mix in HTML and JavaScript all in the same file. Okay. React organizes its code into components, which are just reusable modules, essentially, where you can organize your code and then reuse them. So you can see multiple React components here. You can see this app component is a function right here. Here's the app component. We've got other components here on the side, like the navigation component, which we're pulling in right here. All right, navigation.js. All right. And that's exactly what we want to customize right now is this navigation so that we can make it look like, this screenshot right here. Okay, so let's go ahead and do that. So inside the nav component, we're going to look inside of here. So this is a function for the component navigation. Then we have this return for the function, which returns some HTML. So this nav is actual semantic HTML. So it is an element called a nav. Okay, and inside of here, what we can do is code a div. All right, and then we can say h1. We call it Dapp chord. Okay. And then we can also give it a class name equals nav_brand. All right. And let's go ahead and take a look and see what was done there. All right. So we got some progress. All right. And the next thing we want to do. All right, so we're not actually seeing this come up on the page because we're not actually rendering this component, so my fault. So basically what we're going to do is you can see this welcome to Dapp chord thing here. All right, let's go put an exclamation point here. That's what we're actually changing. Okay, now you can see welcome to Dapp chord. It's got the exclamation point on it, and if you take it off, then boom, it goes off. All right, so we don't want this anymore. What we want to do is take this navigation component from here, which we've imported, navigation. All right, and you can see it here. And what we do is just lay it on the page like this. Just say navigation. And then do an ending tag just like that. All right, now that looks a lot better. Dapp chord. We can see the text that we just added inside of there. Again, you can put an exclamation point or something like that just to make sure that it looks right. Yeah, awesome. Okay, awesome. So one thing I want to mention here is that we have a bunch of style sheets written for you. So this CSS, our index CSS, the project is already styled. Okay, I don't want to spend a bunch of time writing CSS in this tutorial because really we're going to focus on the blockchain side of things. So whenever you do stuff like do nav brand, it's going to automatically pick up the styles that are pre-done for you, and it's going to automatically start looking a lot more like this sort of mock-up of the final project. Okay, so we're getting close. So the next thing we want to do in terms of layout is put a button here. All right, we're just going to do a button. All right. And then we'll call it type button. And then class name. is going to equal nav_connect. All right. And then it's actually going to have a closing tag. We're going to do it like this. And then we're going to have a closing tag like this. And what it's going to do is say connect. All right. And then we'll put it like this. Yeah, it's looking a little bit better. We need to fix this. It's not looking quite right, but that's some good progress. All right, so you'll notice that whenever we close this, that it'll show the right size. Okay, it'll look a lot more like the actual final mock-up here. Okay. All right, so that's looking better. So now what we need to do is actually click this connect button and make it work so that we can pull our wallet in. And so what we're going to do is go ahead and load our account inside of this app.js file. Okay, so I'm going to show you how to do that. All right, what we're going to do is create a React hook, all right, which is basically just a function that's going to let us run whenever our component is loaded. We're going to call this, we're going to call a function here, okay? We're going to call it const load blockchain data equals async. All right, and then inside of here, we're going to say console log loading, all right? So I've defined this function, but if you go to our page here, you're going to see it doesn't actually show you that there's any console logging. All right. In fact, it's showing a bunch of errors. We'll clear out those errors here in a minute. But let's actually make that work. So we're going to use something called useEffect, all right, which is a React hook. All right. We've already got useEffect imported here. This is a part of React. And so you can just say useEffect. And inside of here, we can call load blockchain data. All right, now if you go here, you can see it's loading. All right, so let's explain what that does. It's basically useEffect is a function that's going to get called whenever this component renders onto the page. All right, and then inside of useEffect, we can do whatever we want to. In this case, we want to call this function, which we defined here, called load blockchain data. And inside of here, we can basically boot up our app and make it connect to the blockchain. So the first thing that we're going to do is get our accounts from MetaMask, all right? And I'm actually going to show you how to do that in your terminal, or not your terminal, but your console here. If I put this inside of here, this const accounts equals await window.ethereum request method eth request accounts. You don't have to do this. I'm just going to show you. It will actually show the accounts that are returned from MetaMask right here. And this is really noisy. If you want to kill the noise on this, one really easy way, inside your app.js file, just take this socket line here and just comment it out, okay? And then if you refresh the page, all that should go away. Okay, so basically, well, I'll say that. You might have to do it in another thing. We'll get to that part later. For now, we probably won't do much in the console. All right. So, but I'm going to do that line here. Const accounts equals await window.ethereum request method eth request accounts. All right. If you want to pause the video and copy that down, you can. And what I'm going to do is do this next line, const account equals ethers.utils.get address. And then I'm going to get the first account, all right, from the list, account 0. And then I'm going to do console.log account. All right. So if you want to copy that down, you can. All right. So now if I go back to the console here, and it's going to be kind of noisy, but you can see that the account was logged right here. That's the one that came in from MetaMask. Okay. So what we want to do is get this, all right, and then we want to set it to the React state. So what is that? Well, the React state essentially is the thing that lets us save information inside of our app. So if you look at this to-do app right here, you can see like, hey, what needs to be done? Item 1, item 2. How does React know where these items go on this to-do list? Okay, they get saved into the React state object. That's what it's for. It's like a little front-end database for your app. Okay, so basically we can just add those like that to the React state. So how do we do that? Well, we can use other React hooks from this. We can do use state. So we use effect here in React. We can also do this use state, which is imported, which we can get things from the React state and write to it like this, okay? So we can just use this, we can use this thing called use state right here. All right, this is a function, all right here. And we can assign, if the function is going to return an array, okay? And what we can do, it's going to return an array of two different things. One is going to be a variable of the current value, and the other is going to be a function that's going to let us set the value. So I'll just show you what that looks like. We say const account, and then set account equals use state null. So what this does is React gives us a variable to read the account from the state, and then a function to write the account to the state. And we use default value as null if there's no account in the state, okay? And so down here, instead of console logging the account, we can just do set account as account, okay? And then now if you wanted to access that on the page, right, down here, you could just do like, navigation, H1, and then you could say account. All right. And then if you go back to your page here, you can see the account listed on the page. All right, looks terrible, but that's showing you that you can basically get your account from MetaMask, save it to the React state with set account, and then you can use the variable, like this here. All right. So what I'm going to do is not do this here. I'm going to do it inside the navigation, because what I want to do is go into navigation, click connect, and then that's going to pull our account from MetaMask and then show it on the page. So what we want to do inside of here is create a handler to do that, okay? So I'm going to show you how to do that right now. It's pretty straightforward. I'm going to do this. So button, type nav connect. We're going to do this thing called onClick. This is an onClick handler. It's going to just say connect handler. This is going to be a function that we create, all right, like this. So basically, connect handler is going to do this. Say const connect handler, all right, equals async. And then what I'm going to do here is just do console log clicked. All right, let's go back here. Let's see, connector is undefined. Let's just copy and paste. So this should be capitalized as Y. All right. And let's just see here. If I do that and click connect, you can see it's clicked. All right, so it actually console logged that. It's kind of annoying with all this output. Sorry about that, everybody. But that's how it works. All right. So now what we want to do is, if we've connected, we want to go through this routine of, connecting to the blockchain. So we need to do a couple things. So let's take this account off the page. We don't need that anymore. All right, you can see it's gone. And then in navigation, what we want to do is pass down account and set account like this. So we actually want to pass down these functions, this variable and this function. We can do that like this. It says account equals account, and then set account equals set account. All right, and then those are going to get accepted right here and saved as these named variables. So account and then set account. We've already got that pre-populated to the function, and we'll have access to those down here. Okay. Now what I'm going to do is take out this from the low blockchain data. All right. That's going to be empty for now. Okay. And we can go inside of here, and on the connect handler, we're going to put that same code inside of here. So instead of click, we're just going to replace it and say const accounts equals this, and then set account. And then actually, if you really want to, you could still show the account on the page. You could just say H1. All right. All right. And then we could do this and then click connect, and then boom, there you go. Your account's on the page. Refresh, connect, account's on the page. All right. So that works. Let's take that off, because ultimately what we want to do is show our account up here in the URL bar. So how we're going to do that is basically inside of here, we can do some conditional logic that just says if the account exists, like this account, question mark, This is called a ternary operator in JavaScript. It's just checking for true or false statements. If it's true, do this thing right here. If it's false, do this other thing right here. Okay, so if the account exists, what we're going to do is show one button, all right? And if it doesn't exist, we're going to show a different button, all right? So you could say like, you know, button 1 and then button 2. So if the account does not exist, all right, we're going to put this button that says, hey, connect to MetaMask inside of there. And if the account does exist, what we're going to do is copy this, put it in there, take off the onClick handler because we don't want to click anything, but we're going to show the account on the page. All right. All right, say that. Go back to the thing. And now you can see the accounts there. All right, so click connect, and you can see the accounts there. Now, it overflows off the button, which we don't want. So we can abbreviate it like this. Basically, we can use the slice function in JavaScript and say account slice 0 through 6, and then use ... in the middle and say account slice 38 through 42. All right, and you can grab this from the final code solution, or you can pause the video and copy that down. All right, and so now that looks correct. So now one final thing I want to do is inside of app.js, I want to add this to the load blockchain data. And basically say, whenever you change accounts, we want the page to change. So I'm going to add this function here that says window Ethereum on accounts changed, async, add this function, window.location.reload. So what this is doing is window.ethereum is injected by MetaMask. That's the same thing that we're looking for right here, window.ethereum request. This is listening for the event on accounts change. So anytime we change an account inside of MetaMask, this is going to run, and then window.location.reload just refreshes the page. All right. So basically, if I go here, and then now I change to Hardhat 1. All right. You can see that I get the connect message again, and now it connects my new account. All right. So that's a nice bonus. All right. Awesome. So now we are all done with the Navbar. All right. So now what we're going to do is work on the channels. Okay, so we have essentially worked on, getting the Navbar done. Now we're going to actually lay out the channels. So let's do some basic scaffolding first. What we're going to do is go to our, main section here. All right, you can see this main, and we want to keep the navigation outside of that. But we're going to cut a couple components and just go ahead and lay them out. So we see servers, channels, and messages. Let's just copy all these. Okay, and we're going to paste them down here. Okay, and then we're going to just do this. And we're going to lay the components out on the page. Now, they're just placeholders. Okay, there's nothing really that's going to work yet, but I just want it to look more like our mock-up so that we can see kind of where we're going, all right? Once you've got that in there, you'll see something that looks a little nicer than what we've been working with, okay? Just placeholders, nothing actually worked. If you click on something, nothing does anything, okay? We're going to fill all this stuff in. All right, so servers, channels, messages. We can see these components are here in this components directory. All right, servers, messages, and then channels. And then we got navigation, which we just finished. So for servers, you can see this is like sort of the Discord like servers right here. These are the channels inside the server, okay? So essentially, like this is just going to be like kind of placeholder. We won't actually wire these up to do anything. If you want to create a full-on Discord app, of course, you could wire the functionality up for this. But for now, what we're going to do is just kind of keep you on this server, and then you have NFTs for each channel inside of here, okay? And for the text channels. So you don't see any text channels yet. That's because we're actually going to get them from the blockchain. Remember, we created the channels in the script. So let's go ahead and load our blockchain stuff up, okay? We already have this load blockchain data here, but what we can do essentially is go ahead and connect to Ethers.js. So what we're going to do is get an Ethereum provider, right, from MetaMask, just like we did in our tests. So we're going to do that like this. We're going to say const provider equals new Ethers providers, Web3 provider, and then pass in window.ethereum, which we use for the MetaMask accounts. So So again, Ethers is the library that's going to turn our application into a blockchain application. It's the JavaScript library. We used it in the test. We can also use it on the front end. So we say Ethers providers, we have the provider, and then now we can use this to actually talk to the blockchain. So we're going to save that to the React state, just like we did with the account. All right, we're going to do provider and set provider at the top, just like this. All right, and then we're going to call set provider right here. And the next what we're going to do, we need to actually fetch our smart contract Dapp cord. This is the NFT that manages the channels. And so we need to talk to it and make sure people have the NFTs before they join the channels, and then also let them buy the NFTs whenever they want to join it. Okay. So in order to create that smart contract, make sure that you have filled in your config.json with the appropriate address from Hardhat. Okay. And then make sure that you've got the appropriate ABI here in the ABIs section again. Okay. I talked about that in the deployment step. Go back and check that if you haven't already. So if we have the address and the ABI, that's all we need in order to create a JavaScript version of the NFT contract and start talking to it. So if you look at Ethers contract, the docs, this is how you create a new Ethers contract. Basically, you give it the ABI, abstract binary interface, and the address. Okay, and then essentially you give it the provider as well, and that's how you create a new contract. So new Ethers contract, address, ABI, signer, or provider. Okay, so let's just copy that and put it in there. So we'll say const Dapp cord equals new Ethers contract. So the address, where's that going to come from? I'll show you in a minute. Signer or provider. So provider, we have that saved to a variable from here. All right, where's the ABI coming from? Well, if you look up here, we've got the ABI imported. So ABI is dappcord.json. We just call it Dapp cord. So we put that right here. All right. And then how do we get the address? Well, basically, we just get the address from this config file right here. So you can see inside this config file, we could just get this address and then paste it in here. All right. But really what we want to do is read it from that file. So essentially what we're going to do is say this config, and we want to dig into this chain ID, which is this. All right. So config 31337 dappcord.address, and then pass in the rest. But we also want to fetch this network ID directly from MetaMask. Okay, so we can fetch that network ID like this. Say const network equals await provider get network, and then just pass in this network right here. Okay. And then once that's done, we can do, we'll have a JavaScript version of the smart contract. Okay. And we can just do set Dapp cord and get Dapp cord just like this. And then we can do set Dapp cord. And then let's do this. All right. So let's do a quick smoke check. I know I went through a lot of stuff right there. Let's just do a smoke check in the console. And what I want to do is do console.log dappcord.address. Okay, to make sure that this worked properly and that you can actually log the dappcord.address from this variable, which we've set, okay, like this. So let's go to our app. Let's open up our console and let's see here. All right, cannot read properties of undefined reading Dapp cord on line 32. All right. All right, so let's pull this over. Let's make sure this looks right. All right, so I think what's going on here. Let's do that. All right, now we can see the Dapp cord address on line 35 right here. So I had just a little error in this line. If you want to pause and record the, pause the video. I passed in network, I believe, and didn't call the chain ID. So you had to do network.chain ID. My fault. Okay. So Ethers contract config, you're reading the network.chain ID from that, then you're getting dappcord.address. Again, you're going the chain ID, Dapp cord address. That's what we're doing right here. Okay. And then passing in the Dapp cord ABI and provider. It's kind of confusing, but that's what's happening. But anyways, we've logged the thing to the console here. So you can see that's working. Okay. And then what you're going to do is load up the channels. Okay. So what we can do is we can get the channel from the blockchain. We can say await Dapp cord get channel. Because again, inside of our Dapp cord, we have a get channel function here. We can pass in the ID. So let's go ahead and get channel 1. All right, say const channel, and let's console log. All right, so you can see it here. It's a struct from Solidity. So you can see here's the thing. It's the general channel. Okay, is the name is general and the length's 3. All right. So it's actually doing that. We can do the same thing for channel, 2. All right, and then there you go. It's the intro channel. So we're able to successfully get channels back from the smart contracts. We know it's working. We're calling this function get channel. So what we're going to do essentially is we're going to use a for loop to loop through all the channels and get them one by one. So how do we do that? Well, basically, I'm going to clear this out. But the first thing we're going to do is get all the channels. So we say const total channels. All right, then console log that. Basically, we're just fetching that total channels. Again, that's on the smart contract. Total channels is a function right here. All right, so that tells us how many channels there are. You can see that's here. It's a big number. You can call it toString if you want to. All right, and then see it's 3. Okay, and so it knows there's 3 channels. So what we're going to do is put those into an array. All right, so we're going to do an array called channels. And then we're going to use a for loop inside JavaScript and call get channel for each item in that. So we do that like this. All right, and you can pause the video if you want to copy this down, but I'll explain it. So basically, we're using a for loop just like we did in our deployment script. So you can see we used a for loop to create channels. So we did that 3 times, right? Boom, boom, boom. And then we create the channels. Here we're doing 3 times and we're fetching the channels and pushing them into an array. Channels push, that's how you add new items to the end of an array with the push function. All right. And then we're going to save those to the React state. So at the top, we can do, just below Dapp cord, we can do const channels, set channels equals use state, and then pass in the empty array. All right. And then essentially below here, we can just do set channels. All right. And that's going to set the channels inside of there. We can also do console.log channels just to see that it actually worked properly. All right. So it worked. And here's our console log. Sorry, that output's really annoying. We'll fix it shortly. But general, intro, and jobs, it got all 3 channels. All right. So now what we're going to do is we're going to, we've loaded all the blockchain data. Now we're going to use the channels on this sidebar. Okay, so in the channels directory, or in the channels component, what we're going to do is pass in several things, just like we did here with the account. We're going to say provider is going to equal to provider. All right. We're going to do several things. We're going to say account is going to equal to account. All right. So Dapp cord, we're going to pass that in lowercase. That's the contract. We're going to pass in the channels. And then, we'll just start there. Provider, account, Dapp cord, and channels. Now if I go to this page, nothing's really changed. But the next thing we want to do is list out those channels we just loaded here on the text channels page. So let's go ahead and go into this channels.js. All right, we see that the voice channels are listed here, channel 1, 2, 3. Those are just sort of fake channels, placeholders. But now let's actually go ahead and list out the text channels right there. So what we're going to do, we have the channels here. So we can basically loop through these. We can do this inside of React. We can say channels.map. Okay. So this is a function that lets you loop over an array. Okay. And what you can do is list them all out like that. Okay. So what we're going to do is inside of an unordered list, so UL, and then basically we'll have a list item for each channel like this, like list channel 1, channel 2, channel 3. All right. But we want to create this dynamically. So basically what we're going to do is, let me just show you. Take this out. And we're going to put this inside of here. Okay. And we're going to do li. And then we're going to say channel name. And they're also going to do this key is index. All right, let's go see if that worked. All right, if you want to pause that, you can see. Check that out. Okay, all right, let's see if it worked. All right, it did not. Well, let's connect first. All right, I don't think that it worked yet. Let's just give it another shot. Okay, all right, so it looks like it's not working. Let's see what's going on here. All right, so I know what it is. So basically, we just need to change this curly brace to a open and close parenthesis. All right, and that should work now. All right, there you go. Awesome. Now I can see like the general intro and jobs. The channels are actually listed. So let's kind of explain that. So first of all, when you're doing functions like this in JavaScript, there's an implicit return versus not one. In this case, we weren't returning the list item. And if you use, this parentheses for one-liners like this, you'll be able to do that implicit return. You don't actually have to put a return here. So we created an unordered list. We mapped over the array inside JavaScript. You can use these curly braces to put things on the page. And then we put this new thing inside of here. We use the channel and we call .name on it. And then because these are going to render multiple list items, React requires that we have a unique key for each of those. And so we just use the index of the item in the array to do that. Whereas if we take it away, React's going to yell at us. Okay. All right, so now what we're going to do is let the user choose the channel. Okay, so for this list item, all right, what we're going to do is we're going to break this up. Let's do it like this. All right. And what we're going to do here, let's just see, actually, let's do it like this. Hold on, gets kind of confusing sometimes. We're going to have this on-click handler. All right, and so what we're going to do is say on-click. And we're going to say channel handler. Say channel. Okay, so this is a new function that we're about to create. We're going to pass in this channel. And so at the top of our function here, we're going to say const channel handler equals async, and then channel. Okay, I'm going to say for now, I'm going to say console.log clicked. Okay. And let's just make sure that when we click this button, we call this function, and that's going to log it to the console. All right, so general clicked, intro clicked, jobs clicked. Awesome. All right, so it's working. So what do we want to do? Well, we want to join a channel. Anytime this happens, we want to change the current channel. But the first thing we want to do is, essentially make sure that the user has joined, okay? So if they have not joined, if they don't hold an NFT, we're going to make them purchase it, okay? So we can connect to the blockchain just like this, and we can see if they have joined the channel, because inside this Dapp cord, we have this, has joined. Right here, has joined. We can pass in their address to see if they've joined the channel. If they have, we'll just let them view the channel. But if they haven't joined the channel, then we're going to require them to buy an NFT for that channel. Okay. And then once they do it, they can view it. Okay. So inside of channels, what we're going to do is basically check the status at the top. We're going to say const has joined equals await Dapp cord has joined, and then pass in the channel the ID and then the account. So the channel comes from here. We get the ID and then the account, which comes from here. So basically, then what we're going to do is say, let's say if has joined, say console log joined, else, console log has not joined. All right, so when I click on these channels, it should show me that I have not joined. You can see if I click general, it's like has not joined, intro has not joined, jobs has not joined, okay? So that's fine. So what we're gonna do is basically make it buy an NFT in order to join the channel, okay? So how do we do that? Well, basically we call the mint function just like we did, in our tests. So in order to do that, we need to get our wallet. So we can do const signer equals await provider get signer. That's going to return the signer from MetaMask, which is going to be the, the account that we're connected with. And then basically, we can say await dappcord.connect signer. Okay, so that's the person that's calling the function that's paying the gas fees. And then we can call this mint function, all right here. So we just got to pass in the ID. It's called mint. Pass in the channel ID. Okay. And then we, of course, need to pay some cryptocurrency to do this. So let's say value equals the channel.cost. Again, the function metadata value is the amount of Ether that's getting sent in with the transaction. And we just hard code that to the channel cost. Okay. So we can say that to a transaction, say const transaction equals this. And then we just say await transaction wait. Okay. So now if I go here, click connect, and when I join the general channel, it's going to have a MetaMask confirmation pop up, and it's going to show me the cost, which is 1 Ether. Click confirm, and then now I have joined the channel. Okay. And now if I go back here and refresh the page, connect my MetaMask, click general. Actually, hold on a second. Let's just do that. Hold on. All right, so it failed to mint. So here's an issue. Sometimes whenever you restart this, okay, you're going to want to reset your account. So I'm glad I saw this on screen because I want to show you this. So if I go to advanced settings, restart account, click reset. And now if I see my transaction history is clear, it didn't actually delete anything on the blockchain, but it refreshes the cache so that I don't have this problem. So sometimes this happens. So I just reset my account, click general. Let's click mint, confirm. And then now I should see a successful mint in my wallet because before it was canceled out. And now if I click the general channel, it's going to see joined. Okay, that's important. It's joined. All right. So now the final thing we want to do is update the current channel. Okay. So basically in app.js, what we're going to do is get the current channel. And then we're gonna create this with a React state like this. So like we have channels and set channels, we're gonna have a new one that just says current channel and then set current channel. But we don't want to make it an array. We just want it to be, null by default, right? So boom, const current channel and then set current channel. A current channel, set current channel. All right. And then we want to pass these down here. So we want to add just below this. We want to say, all right, current channel equals current channel and set current channel equals this. And then while I'm here, I'm going to improve this spacing a little bit. Okay. All right. And then now inside of channels, we're going to update that. So if we do has join instead of join, we're just going to say, set current channel. And then we're going to pass in the channel. All right. And then what we're going to do is show or not whether or not this channel is active. Okay. So below this onClicked, we're going to evaluate the class name. So we're going to apply a special class to it. So let's say class name. Okay. And then basically what we're going to do is say if current channel and current channel, the ID to string is equal to channel, the ID to string. Okay. And we say active, or it's just empty string. So basically what it's going to do is going to check if this channel is active. If it is, it's going to apply this active class. And if not, it's going to apply any class. Okay. And now we can see if I click general, I'm going to click connect, hold on. And click general. Now it should be active. So let me just make sure this looks a little better. Hold on. Yeah, it looks better. Class name, current channel, and current channel ID string. Okay, awesome. Now that looks better. Okay, so now I can see that it's actually active. Connect. All right, click general. Now I've joined it, and you can see the general stays highlighted, and that's the exact code for this line. Okay, if you want to pause the video, you can do that, or you can grab it for the final code solution. Okay, so the last thing we want to do here is whenever we join a channel and it's successful, we want to set the current channel after we mint the NFT for that. Okay, so for example, like we haven't joined this intro channel, but when we do, we want to actually pay the cost to do that. And then whenever it's finished, we want it to highlight and join that channel. So that's what set current channel does here, all right? So let's save that, refresh the page. Let's connect our wallet. Okay, we can join general. But now what we're going to do is join intro, and we have not joined that before, so it should ask us to mint, and then once we've minted, it should join it for us. All right. So let's do that. There's no cost because it's free, but we need to add it to our channels, and then boom. All right. Now that it's finished, you see this automatically highlighted here. Okay, general. And then if you want to join jobs, you can pay the cost to do that, and it should also buy the NFT, and then boom, there you go. You've paid the cost for each thing. So there you go. So our NFT is on a per channel basis, right? You can always modify this to be a per server basis where you just buy the NFT. You got access to the entire server, but this is sort of like permissioned access to each individual channel on that server. All right, so now let's get to the fun part, which is chatting, okay? So just a quick review of how our website works here. A person uses their wallet, they connect to the browser, they go to this website, and it's going to talk to the blockchain for the NFTs, but it's also going to talk to a separate server that allows us to do chat messages. And so how do we do that? Well, we're going to create a server in a second, okay? And we want a server that meets our capabilities. So first of all, we're going to use Express.js, which is a JavaScript server framework. You can basically create any type of server you want to, all right? And so we're going to create a server with Express.js. But we also need a server with real-time capabilities, WebSockets. And so we're going to use the socket.io library for that. Basically, this lets us use WebSocket communication with our servers so we can stream messages and, post messages to it. And this is perfect for like a chat room, because what you don't want to do is like create a chat room. It's always like trying to look for new messages and then add new ones and go refresh the list. Basically, it's going to have a live stream of all the messages that are coming in through this type of thing, okay? And that's exactly what we're going to create right now. So if you go into your project here, let's just close down some of this. All right, we don't need all this. You're going to see this server.js file here, okay? So our blockchain stuff is inside the contracts directory. Our front-end stuff is inside of the source directory, and this server.js script is literally the done for you script that's going to let you do chat messages. Okay, so I'm going to collapse this messages here so you can see how this works. Basically, this is just a single file, that imports Express, saves it to this variable here. That's the JavaScript framework package. App basically just calls the Express function so you can create an app. It does some basic configuration, like tells you the port, which is going to be running on port 3030. All right, that's different from 3000, which is what our blockchain is running on. So we want to change that, do port 3030. And then basically we say server equals app listen on this port. And then we do console log listening on this port. And then we have some messages, which I'll show you in a second. And then we, import socket.io right here. Okay, we do a capital S server. And then we create a new socket.io server from their documentation, just like this. We just say IO equals new server. And then we do on IO, which is what they tell us to do. And then pass in the connection. Once you get connected, it's going to have these different things. Okay, so basically what it does is it listens for events. And whenever certain events are emitted, it will do other things. So basically, like when it gets a get messages thing, it's going to emit get messages, and it's going to pass in all the messages which you saved here, okay? And then when it receives a new message from the chat room, it's going to take that message and add it to these new messages and then return the list of the entire messages, okay? So we have created some messages pre-populated for you, okay? It's going to be basically just a big array, and each one has a messages object, which just has a channel, okay? An account that sent the message, and then the text for the message, okay? And so we've got these pre-saved already for a bunch of different channels, channel 1, 2, 3, et cetera, et cetera, et cetera, all right? And then what it's going to do is this array is we're going to save all the messages. And so when we load this up, we can just load all those up into our respective channels. But then whenever we have a new one come in, this new message, it's going to add the message to the end of this array. We're going to create a new channel right here. Okay. And then it'll return the entire thing so we can, refresh and make sure that we are showing our messages properly. Okay. So this is basically done for you, but I want to explain how it works. All right. So we can open that in a new terminal tab. All right, we can do to our starter code. You got your front end running here and your blockchain running. All right, and then we're gonna do npm. Actually, let's do our script here. Let me see what the command is. We're gonna do node server.js, and then now you can see listening on port 3030. A user is connected. Okay, so we can see a user connected. It works. All right. And now we want to make sure our app is connected to the server. And so if you go into app.js, we've imported this socket right here. So we've imported IO from socket.io client. And we basically just say const socket equals IO. And then we pass in the WebSocket protocol for localhost port 3030, which is the exact port that we're running on right here. You can see listening on port 3030. All right. And that's really the only basic configuration that we need to connect to our socket. Now, what I'm going to do is I'm going to show you this link. All right. So I'm going to put this in here. Here's the documentation on socket.io and how to use it with React hooks. So this tells you how to use your socket.io and connect it to your React component inside of use effect. So we're using use effect, so we can do socket on connect, socket on disconnect, socket on pong. All right, so we're going to use that exact configuration. All right, and then adapt it for our use effect function here. So I'm going to paste that inside of it so you can see it later if you want to. All right, and then what we're going to do is do exactly what they say. We're going to say like on socket on connect, and we pass in a function, and then I'm going to say console.log socket connected. All right, we go to our terminal, our console, and we look at this up here. Let's just refresh, and when I refresh, I can see that socket connected. Okay, so we want to duplicate that for all the other things we want to wait for. So I'm just going to copy this. All right, we want to look for a connection. We want to look for, let's just pull this up here, the server.js. We want to look for a connection. All right, we want to look for get message, right? So it's IO on connection, on get message, IO on new message. And we're going to perform actions anytime we do that. So on get message, or new message, sorry. All right. And then on get message, messages plural. All right. And we're going to say getting messages. All right. And then, on new message. Okay. So let's just save that. We go to our terminal again. Let's just refresh. I keep saying terminal, I mean console. Okay. So you can see the socket was connected and we're not getting anything else because we need to join a channel. And then that's when we need to actually do it. Okay. So what I'm going to do is one last thing here. We need to do this configuration, which is return, all right, at the end of use effect, because this is exactly what the documentation tells us to do in this link. So we introduce socket off. When it goes off, click connect, socket off, new message, socket off, get message. All right, let's save that. And then let's refresh. Make sure we don't break anything. All right. All right, it's looking good. Click connect. And we don't see anything yelling at us in the terminal. In the console, it's way more quiet. All right, so next we actually want to fill this in. So after socket connects, we're going to do socket.emit get messages. Okay, so the whole idea is once you've connected, we actually want to get the messages from the server. All right, and now we should see those logged. All right, so let's go to our thing here. All right, so socket connected. And then, boom, you can see getting messages is logged, okay? So actually, instead of getting messages, what I want to do is actually log the messages. Okay, I do that here and then do that here. And then instead of getting the messages, I'm going to actually log the messages themselves. All right, so let's refresh. And once I've refreshed, I can see that the messages are actually logged to the console right here. You see the channel, the user, and then the message itself, okay? Awesome. So I've got the messages. Now, instead of logging this to console, I want to save them, all right? So we're going to save it to the React state, just like we did the other stuff. So at the very top, I'm going to do, just below channel and current channel, we're going to do messages and set messages and do use state. It's going to be an empty array. So we're going to store everything in an array inside the state, okay? And so what we're going to do is basically, whenever we get the messages, we're going to set the messages right here, set messages, and then pass the messages. And then likewise, whenever we chat a new message and it returns all the messages, we're going to update that list right here. Okay, so set messages. And that should be everything for our socket.io configuration. Okay. So now we're actually going to code out, doing chatting inside this messages box. So the next thing we want to do is pass in some parameters down to this messages component right here. We want to pass in the account, the messages, and the current channel like this. Okay. We're going to say account equals account, messages equals messages, and then current channel equals current channel. All right. You can pause that if you want to check that out. And then inside the messages.js, we're going to fill this in to start doing some chatting. All right, so let's go ahead and start filling out this messages component, okay? So the first thing that we're going to do is actually put the messages, inside of there. Okay, so what we're going to do is basically just, let's just do this first. All right, so we're going to say messages, and we're going to say map. Okay, we're going to say message index. And then we're going to do this. And we're going to put the messages on the page, okay? So we're just going to do div. We're going to say class name equals message. And then key equals index. Okay, and then we're going to do, for now, let's just do message.text. All right, let's see if that works. Let's go here. All right, click connect. And then, boom, I can see welcome to Dapp Core. You can see all this type of stuff, right? But there's a problem with this. If I can also show you, I can show you the channel. And we're showing you, like, if I was going to do this, I did message.channel. it's going to show you all the channels like from different ones, right? This is channel 1, this is channel 2. And we want to filter through the messages so only the messages in channel 1, show in general, right? So how do I do that? Well, basically, I can use a filter inside of JavaScript. So I can say messages.filter. And what I can do is make sure that it only does from the current channel. So basically a message and then message.channel is equal to the current channel.id to string. Okay. And then now you can see only channel 1 pops up. All right. So I'm going to take out this, channel number here. I just wanted to show you that that's the case. All right. I think I might have blown something up here. So let me just... So on caught property null reading ID. Just do that. All right, so we're good. General. And so to fix this problem, we also want to make sure that the current channel exists because we're checking for the current channel ID before it's loaded. So basically we could say current channel. All right, and once that exists, we can then filter by the current channel. All right, so then if I go back here, first page, it doesn't absolutely blow up on me, okay? So click connect, and then once I join a channel, it's gonna show me the messages from that channel, okay? And then messages from intro, and then jobs, etc., okay? All right, but if I just refresh the page and I haven't connected my wallet yet, it's not gonna show me any because I haven't actually joined the channels. And if I go, like to another account, Hardhat 1, for example, it doesn't have any NFTs, I can't see the messages, right? It's gonna make me mint the NFT, all right? All right, it doesn't show it to me yet because I haven't set the current channel. So reject that transaction. It's going to change back to our other account here. All right. All right, so now I'm going to format this message and make it look a little bit nicer. You can grab this from the final code solution if you want to, or you could just copy it from pausing the video right here, okay? But this is basically what we're going to do, okay? So basically, we're just going to, make that look better. All right. And then I need to put this over inside the better. Okay. And then we're going to say messages, key index. We have an image here, source of a person, which is already imported up here. And then class name, message content. And then we're going to, get the account, show it inside of there, truncate it, and then show the message text. And now if you go back to our site here, click connect, go to general, these messages look a lot better. Okay. You could upgrade this even more. You could put like identicons inside of here for each Ethereum address if you wanted to, but for now we're just doing a little placeholder. That's a great homework assignment. It would basically be, look at my other tutorials where I've put like block keys or identicons inside of there that are generated from each Ethereum address, and you could easily do that to sort of give everything some uniqueness to it, right? So last thing we want to do is use a ref to do the message end, all right? So we're going to create this at the top. Basically, a ref is something in React that just lets us store a reference that we can add later, okay? And then we're going to use this div at the end to store that ref for the message end. And then we'll see that here, okay? Because what it's going to do is automatically scroll when more messages come up. All right. And so now what we're going to do is create a form for chatting. All right. So we're going to do a form right here. All right. And then it's going to have an input. Let's say on submit. It's going to be send message. We'll create a function for this in a second. But really what we're going to do is have an input, type equals text. Okay. And then that's going to be, the channel itself. And then we'll have a button to submit this. And then button, type submit, send, send message. All right. And then, okay, send message is not working. Let's just say on submit send message. Obviously, we've got to create a function for that up here. So we're going to do, just const send message. All right, it's going to equal async. Pass in an event here. And we'll call the function here. And we'll just console.log. Sending message. And then we'll just pass in, let's do that for now. I'll take this out. All right, now let's go to our thing here. Now we can see this nice thing. I don't know if I'm clipped off the bottom of my screen, but you can see that. And I'll say, hey, everybody. And then I click this and it pretends to send it. So the first thing we need to do inside of here is prevent the default behavior, because HTML forms by default send a post request and refresh the page. So we're going to say e.prevent default. Okay. And so if I go back here and then click connect and do, hey, everybody, we need to join a channel first and hit enter. Okay. Well, let me make sure it's saved. All right. All right. So send message. Let's see on submit. Okay. Let's try it again. Let's just say, hey. Let's just see what it's doing here. Not sure why it's still refreshing. Let's see if we can kind of debug here. Click hey. Click that. And so I see what the problem is. I have a typo here, so it's not on some bit, it's on submit. All right. So let's try that again. Sorry, everybody. It happens. I like to leave these on screen because that way you see what it's like to be a real developer. And then let's click on general. And then I'll say, hey. All right, now it says sending message. Okay. So now we want to keep track of the message. So inside this input, what we're going to do is basically have an on-change handler. Okay. So basically on change, we're going to say E, and then we're going to pass in set message e.target.value, which is just going to be the I did this on the wrong thing, everybody. Sorry. Let's do this. This got really out of hand really fast. Let's try that again. Wow. I meant to put it on this input right here. So we're going to do that on change, e set message, e.target.value. Okay. So e.target.value is going to be the value that the user inputted here. And we call set message, which is a function that we're going to create right now. Basically, it's just going to be a hook. So at the top, we're going to say message and then set message equals use state, and it's going to be empty string is the default value. And then inside of here, we can reference that message like this. We can console log the message. Okay. So on submit, like on anytime we type a message in, it's going to set the message. And then when we submit it, we can capture that message right here. All right. So let's just refresh, click connect, do this and say, hey. And then that should be logged to the console right here. All right, so that didn't quite work. All right, let's just click connect, let's refresh. All right, we're on. Somehow I lost that again, on submit. The typos abound. I'm not even sure how that one happened. I think I might have bumped something in my text editor. Let's click connect, general. All right, then hey, and then hit enter. And then now, boom, awesome. I can see sending message, hey, that's working. So we're talking to the server. So one final little piece of thing, we're going to send the message to the server. That's going to be the most important final last task. But I want to do a couple things. I want to basically make sure that we have a current channel set. All right. And if it's not, then we want to connect to MetaMask. So let's see here. We've got current channel and then the account, all right? We also want to make sure they have an account connected. So we're going to replace our input with this. And you can find this in the final code solution if you want to, but I'm just going to kind of paste it in for now. It's kind of hard to see completely on screen. Maybe I can, bump this over, but you can definitely find this in the final code solution if you want to. Basically, what we're saying is we want to check that there's a current channel and there's an account. If so, we want to basically do that same input with the value of the message, okay? And then the placeholder is going to be message current channel name, and then we do that. But if not, then we want to have this placeholder, please connect wallet to join the channel, and it's going to be disabled and you can't type in it, okay? So let's do that. Let's refresh here. We're not connected, so you're not joining the channel. You can't go into this and type, okay? So once you've connected, you still can't go into it and type. You actually need to join a channel before you can see the messages, and now you can start sending them in the hey, all right? And of course, it's not going to do anything yet. It's just going to say, sending a message, hey. All right. So there's one more thing we want to do, which is basically have a scroll handler so that when you have more messages come in, it will automatically scroll those. So after set message, we're going to do a scroll handler, which looks like this, scroll handler set timeout message ref end ref. That's this thing right here. Basically current scroll into view behavior smooth. So as more messages come in, it will continue to scroll down. All right. And then we want to call that inside the use effect hook like this. All right. You can grab this in the final code solution. So there's a couple little just optimizations from the UI perspective. But now we want to do the final most important thing, which is post the message to the server. Okay. So inside the server.js, you can see what that looks like. Basically, we want to build an object that looks like this and send it to the server so they can get stored in this array. And so that you can essentially do it on, new message. And when that new message comes in, it's going to push it into that array, and it's going to emit a list of all the messages to make sure that we have all the most recent messages. So what we can do is basically create a message object. We can say const message object equals this. All right. And we say channel. We want to give it the three properties from what we see in the server: the channel, the account, and the text. Okay. So channel, account, text. All right, so the text is the message that's getting passed in, right here. This is the message. We can take that console logging statement out. The account is going to be the account. Okay, and then the channel is going to be current channel ID to string. All right. And basically, we also want to make sure that the message is valid, that there's actually a message inside of there. So we want to say, well, first of all, let's not do that yet. Basically, what we're going to do at the end of that is just do socket.emit, new message, okay? And whenever it's done, we want to set the message and so it's blank, and that we clear out the chat so that we don't have a message still sitting there in our form, okay? And that should work. But finally, what we want to do is make sure there's actually a message so that we don't send a blank message to the server. So what we're going to do is if message is equal to empty string, okay? If it's not equal to empty string, then we're actually going to send it to the server and then, do that. Okay. So that should be everything that we need right here. Okay. So now let's give it a shot. All right. We can actually observe it in the server. User's connected. And then we can go here, click connect, go to the general channel. Hey, everybody. All right, boom, there we go. We can see our user address was stored. Here it is from here. Here it is in here. Go to the general channel. Our message is not there. Go back to this channel. It's still there. All right. You don't always see it in a server. That's okay. You need a console log in order to do that. We could always add that later. Go to jobs. We can say, hey, everyone, here's a great job. Okay. And then it's there. All right. And then we can also, change wallets. And then go to, Hardhat 1. And then, they're going to connect. They need to pay to join the channel. Once they do, all right. I think I might have to reset this account, so let's do that. Settings, advanced, reset account. reset. Okay. And now let's try to do the refresh, connect, intro. Let's confirm. All right, boom. There you go. And we can see it. All right. You can do this channel. All right, boom. We've joined it. We can see the message from the other account. We can say, hey, this is my alt account. Boom. Awesome. There we go. So you have just coded a fully fledged Discord clone with blockchain. All right, so that's an overview of how to create this blockchain-based Discord clone with NFTs, okay? So you've done a lot in this lesson, so congratulations. But where can you go from here? So some really easy ways to improve upon this project are to, put the smart contracts out there on a blockchain, a test network, so you don't have to risk, losing any real cryptocurrency by doing this, and maybe deploying your website live to the web so other people can actually use your application. But some great feature ideas I hinted at a few times for this video is you could take the NFTs and only require membership for specific servers rather than specific channels. Okay, you could add multiple servers. You could even manage unique Discord servers with blockchain. You could add identicons so that people have, avatars associated with their Ethereum wallets. There's so many things. I'm just scratching the surface. But I hope you liked everything you saw in this video today. Again, I put a ton of time into making this video just for you. And the only thing that I ask in return is that you smash that like button down below for the YouTube algorithm and subscribe to this channel. That really helps these videos out so then more people can learn about blockchain. And if you like what you saw in this video today and you want to take your skills to the next level, become a pro blockchain master, break into the industry, increase your salary well past 100K, whatever your goals are, I can show you how to do that over at dappuniversity.com/bootcamp. Again, you don't have to be an expert to get started today. I've helped people with zero coding experience become real world blockchain developers in a matter of months. So that's all I've got. Until next time, thanks for watching Dapp University.